Okay, here we are again with the podcast Beyond Borders. And today we're going to be talking about, continuing to talk about the system in the U.S., the immigration system, technology. And today we have with us a special guest, Mr. Nathan Martin. He is the CEO of Tetracore, which is, and he'll correct me if I'm wrong, obviously, but it is a stack company with components and objects that allows other people to build on top of it. But today he's going to really be talking a little bit about that, but mostly about artificial intelligence, where artificial intelligence has come from, where it's come to, and where we see it for the future. And the thing is that everybody's hearing about ChatGPT and these generative LLM models, but no one really thinks about what it could be in the future. So we want to talk about the great work that you guys are doing and how that will benefit even smaller entrepreneurs around the country and around the world to be able to use it. So let's dive right in. You want to say a few words?
Yeah, thanks for having me. So yeah, you got the description right. Basically, we're designing a full stack enterprise computation platform that's built to help everybody from the small business up to the enterprise, large billion-dollar companies to manage their objects, but do it in a way that is scalable, but that will also help them in the AI realm, right? So we'll dive into a little bit about AI, some of the things like context and all of that everyone talks about, but that very seldom gets into what that actually means, what you're trying to fit into its context window, and all the different things that make AIs tick these days, right, so to speak. So I'm going to try to not go too far into the weeds with it, but I'll do my best as a nerd.
We love weeds. We love weeds. So let's talk about historically. What is considered the most significant takeaway from the decades of AI research regarding the use of computation, how it actually is applied?
Well, obviously computation has changed dramatically, even just at the hardware level, right? I mean, you've got NVIDIA with their new chips, and they're just getting better and better and better, right? So that is one side of it, hardware. The other side, though, is the actual algorithms and the computational heart, so to speak, if you will. That's
Speak to me like a dummy.
AI, right? So what I would say is our traditional train of thought is to try to make an AI that's built around our own human understanding of our own brains, right?
Is that even possible?
I think it's possible in the long run. It's a great a goal to attain, but we haven't actually gotten the best outcomes from going that approach. Yeah. So a lot of, back in the 90s and whatnot, we had the need for AI to the mouse in the mousetrap or in the maze, right? Yeah. Where you've got a video game and you need some character or sprite to go in a predetermined fashion, but that, feels like it's got some autonomy, right? And so lots of algorithms and things were created to do that, but it was all very rudimentary, very simple.
Well, I have a
question.
At
that time.
So a lot of people, you use the word algorithm. What, in the simplest terms possible,
That's a good question.
An algorithm?
I would say an algorithm is a set of instructions, very detailed, that gets you from A to B.
Yeah, right? It's just repetition, right? It's doing something that it takes repetition, right?
It may have repetition inside of it, right? But in you want to get somewhere inside of that, right? Otherwise, you end up with endless loop, and that's not very good algorithm. But a lot of times you're trying to attain something. So whether that's AI, whether that's the mouse getting from A to B, whether that's the sprite in your video game, right? That algorithm is predetermined instructions to get from A to B, right? Now, that may not be an exact set. To say, look, you take 25 steps, you turn left, you take 10 more steps. There's a little bit more to it there, but it boils down to that.
Just computation. Right? And so I guess that segues directly in. So how does the evolution of computing, because that is the actual production of the algorithm, right? That's computational power is what pushes
runs the algorithm.
Right? Runs the algorithm. So how does that computing power impact the effectiveness of AI methods?
Yeah. Well, AI is best, its outcomes are best when it can perform larger and larger computations on bigger and bigger, more data. Yeah. Right? So more data, less time, better results.
Yeah.
So I'll bring it locally a little bit, right? We're training our own AI, right, that we've been working on, and the more that we give it, the longer it takes.
Yeah.
Right? Well, if we can make that more optimal,
Yeah.
the better the outcomes
Condense
are
it
going to be.
down. So what we would call the corpus.
Yeah.
The corpus is the body of data that the AI is using to pull information from. So quicker computation allows for a faster result.
Yeah.
Is it more effective though?
I would say so. Yes, I guess there's two sides of it. There's the user experience, right? We're the human waiting on the AI to respond in some manner.
Yeah.
And we've done some really cool things like streaming the text in to make it feel like you're having a conversation, right? Like we are now. And then there's the other side of it, which is making the I'm going to call it the retrieval layer.
Yeah.
Much better at retrieving more relevant results to feed back into the AI. And then there's the AI itself, right? So
engine.
The engine, yeah. So the AI is a model that's trained on lots and lots of various data that isn't quite as specific as the corpus, but that gets you to that broad knowledge base. And then we augment it with that corpus and feed it in. So if at any point that all of these elements can get faster at computing either the corpus, running the results in the model, all of that, it's going to be better
like
outcome,
a brain,
right? Mm-hmm.
Like a brain that works better than a slower brain.
Absolutely, but you still have to measure the outcomes, and that's the harder part, I would say, is obviously, there's lots of AI companies, there's lots of open source, which is amazing right now. We're in such a cool ecosystem for this, and in such a short period of time that...
And what do you mean by outcomes? Like when you talk about outcomes, are you talking about accurate responses? Are you talking about speed? What are you talking about?
It may even be predictions. So you've got responses from things that that it knows, right? And how it formulates that to speak to the human.
Okay.
There's we've trained on a specific data set and we want it to, within a certain accuracy, predict the next thing. So what an LLM does is it's basically a fancy way of saying we will predict the next word. It's really characters and tokens and all that, but it's basically predicting the next word in a sequence. So knowing that this started with the dog, it's going to be able to say, well, played catch with the
and how does
owner,
it do
right?
that? Based on previous historical data, like what it's taking from outside sources?
It is at a rudimentary level, right? It's a lot of math and I'll give a really good example, right? When you're playing basketball or really anything, football, right? A lot of it's about position, right? And so you're moving around this ball and you've got multiple players in different positions in a 3D space, right? So what they've done with AI is basically we have information that's presented this way, right, to the computer, and we're adding more and more dimensions to it to give it more flexibility, more understanding, right? So when they're talking about like
more players.
More players.
Oh,
so you have more players able to then perform more actions, right? Which means more possibilities, which then means better outcomes potentially, right? So it's not always hit or miss. You could throw more at it and it can get less outcome or less accurate outcomes. You may even throw less at it. Make it a smaller model and get higher percentage outcomes for what it's trained on, right? So there's in my mind, it's almost like the car world, right? We've got all of these different motors, and as technologists, and machine learning and all that, we get to choose what engine goes in where the chassis is, what the the drivetrain and everything. And so we're approaching this point where you can kind of swap them out, right, and interchange them.
That's a good question. So if you're talking about, because as we've seen cars morph over time, the same would be true about the AI, right? So what are the difference between the short-term and the long-term goals when it comes to AI research and methodologies?
That's a good question. I think that there's two sides of this kind of coin, right? You've got the human side where we're trying to minimize the danger or and on all levels that might be the danger to the specific human that just asked you about something that maybe shouldn't be answering about, right?
Like how to build a nuclear bomb.
Yeah, anything like that. You'll get a denial from ChatGPT without trying to go around it, right? But then there's the other side of, okay, how do we get better, bigger data sets? We started out with, we're in 13 billion is the llama, right? And now we're looking at, there's one that's coming out that's in the trillions of parameters. And we're talking about parameters. Those are like dimensions in that ball game that we're talking about. So when you have a trillion dimensions, right, things start to get almost unfathomable for us. And so
I would say that's unfathomable.
So what I think the short term is, we're trying to minimize danger. We're trying to make sure that the response that we're giving to the human is accurate. It's not dangerous, but that's within a margin of error that we can live with, and that it's computational. Its speed and its cost is worth that percentage of an outcome that then that human is taking into their own lives and using it in some way or fashion, whatever the question is. But then there's the long term. Oh yeah, that's exactly why they need a result.
Answer. You need an answer to something. And so you're talking about dangers. You talk about the long term result, but isn't there a danger of data falling out?
Oh yeah, absolutely. Yeah. So I think one of the biggest dangers is the IP.
Yeah.
Right.
Intellectual property for those that are listening.
Yeah. And as a business, that's a lot of times that's all you have, especially as a technology company, right? And these days as an internet company, that is what you have. So when you're using these tools, you have to be careful of users being able to extract that data back out, right? And it's a challenge. Obviously, if you use like a ChatGPT, that kind of thing, you run the risk of being in a shared environment that other people, it could leak into other people's responses,
open,
right?
That's the word open.
Now, to throw them a bone, I think they're doing a great job at minimizing that while innovating quickly and going live quickly. And I mean, it's amazing, right? But it's a big challenge, right? And so I think what they're doing and what everyone else is doing is trying to get the most bang for your buck, but while minimizing those costs, because AI is expensive.
So you were talking about the long-term game. Yeah. So what does that look like?
I think that the long-term game is to, obviously cost is one thing, right? We need to rein in those costs because AI will not be, I don't want to say gimmicky, but it won't be fresh forever, right? So you have to get that cost down to be able to sustain as a smaller company, right? I mean, like IBM, Watson, right? They've been around for a good 10 years, and they've been charging a lot of money for those products. Yeah. But they're very closed loop. They've got their contracts with those vendors, and it's very, very, very known. And now we're getting to this age of trying to get everything into AI. Everyone's going to use AI. Every business is trying to use AI for all sorts of purposes. I think it comes down to cost and accuracy and minimization of danger, right? And a lot of that perceived danger for the long term comes down to, and I'll even throw in cost, right? When you raise danger as a business owner, right?
Yeah.
We think higher cost. Just
and there
inevitably.
Has to be, because the more obstacles you put, the more the AI has to maneuver around those, which causes computation.
Yeah, and liability, right? I mean, if an AI responds inaccurately to something as crucial as legal advice or as crucial as medical advice or anything of the sort, even business advice for a normal, like a plumber or something, right? I mean, if it's dead wrong about its pricing, for example, right? You're getting quotes that don't reflect your pricing accurately. Well, your cost is through
you could
the
lose
roof.
Money.
And then you've got your reputation and everything that falls with it, right? So I think that we're trying to make AI really work within I'm going to call it the traditional business environment, right? Where we have our costs.
And small businesses too.
Yeah, absolutely.
And that, I guess that brings us to another really good question in context of like AI development in the gaming world. Let's take example Chess and Go, right? What are lessons that maybe we've learned from the computational strategies of the AI versus the human-like approaches?
Well, we're limited,
Yeah.
right? So whenever you're thinking of chess, great example. Some of the earliest AI's algorithms were built with that. And what ended up happening is, we started out very similar to where we are now, where we kind of started to try to do things on the human level, where it's like, okay, let's try to understand how us as humans play chess, right? And we might
Mimicking.
think, yeah. And we may, and we may think 8, 10, 20, maybe even up to like 30, 40 steps ahead. But if you're a computer and you're able to brute force through every single possibility on a chessboard, right?
Every permutation.
Yeah. And do it like that, and then keep doing it at every move, right? You end up where the strategy really that has dictated the strategy, and I'll tell you why. They had to move away from the human approach because clearly we could use machines in a way that is much faster than we can even think.
Yeah.
Right. So we did that, and then all of a sudden, chess is beating world champions. Yeah. And it really is apples and oranges, right? We just can't compete. At least not most of us, right? At that level.
Yeah.
Right. So I think that to answer your question, the utilizing the computers for what they're best at instead of trying to make computers mimic humans, I think that has really taken AI from where it was to where it is now.
Yeah.
Right. Where we know that algorithms are great at this, right? We know how to embed things in hyperdimensional space for vector databases and similarity search, and gosh, we even have image search and image generation, and all that stuff comes down to computation, not human understanding, right? I think that there's some level of maybe similarities between how we think and how AI thinks, but I don't think that it's one-to-one. I think that we've tried our best to imbue our essence into these things,
make it what we call anthropomorphized.
Yeah,
make
absolutely.
it more like a human.
Yeah.
And we see that in robots today, where they're putting AI inside the mechanical facility of a robot, and they try to make the robot mimic, anthropomorphize the robot. And I think it's because it's more visually palatable to people